Okay, second part. So sorry about that. My computer wasn't playing ball. So the volume of this solid cuboid. So to work out the volume, we need to do, for any prism, you would do the area of the front face times by the length. With a cuboid, because it's a special type of prism, you can just times all three dimensions by each other. So you've got 23 times 10 times 12. I'm going to be lazy and type it on a calculator. In the exam, I actually genuinely would always try and type it in, just to make sure you're not making any mistakes. Times them together, we get 2760. So 2,760. I'd just be really, really careful and check our units. Centimeters, 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 therefore centimeters cubed. That's fine, that's what we expect. Okay, a solid cuboid is made of plastic. The plastic has density of 0.8 grams per centimeter cubed. Work out the mass of the cuboid. So we're going to need our density mass volume triangle. The way I remember this is the M goes at the top because it's like the pointy bits of two triangles, but do whatever you need to do to remember your density mass volume triangle. If you do forget it, what you can do is you can use the units in the question. So it's telling you density is grams per centimeter cubed. Grams we know measures mass. Centimeters cubed we know measures volume. So it's telling us that density is mass divided by volume. Density is mass divided by volume. So if you forget your triangle, you should be able to reconstruct that in the exam. So work out the mass of the cuboid. To work out mass, let's cover it up. So you've got density times volume. Our density is 0.8 times our volume, which we worked out in the earlier part of the question, is 2,760. Now, if you messed up this part of the question, but you used this in your second part of the answer, you would still then get those marks for this second part of the question. So make sure you've used what you used up here. 0.8 times 2760, 0.8 times 2760 gives me 2208, 2,208 grams. Let's double check my units. It's asking for it in grams. Our density was grams per centimeter cubed. Yep, we're fine. If this now asks for it in kilograms, we'd then need to convert, but it doesn't, we're all good. Okay, question 6, expand and simplify. So again, first, outside, inside, last, or you can use your window method, whatever one you prefer. I'll do the window this time. So we've got y, 2, y, and 3. Y times y is y squared. Y times 2 is 2y. Y times 3, 3y. 3 times 2 is 6. If we're doing this way, I like to do the window peanut. And then you add together the bits in the peanut. So we've got y squared plus 5y plus 6. And there's our answer. Okay, next question. What we're going to need to do here is we're going to need to factorize this. One of these brackets, I'm almost confident, well, very confident, is going to be x minus 2, and we're going to cancel it out. But let's first of all factorize this bottom, okay? So I want two numbers that times together to make 10, but add together to make minus 7. So we know that they're either going to both be positive or both be negative because the product is a positive number. But there's a minus number in the question, so we know that they're both going to be negative. So what two things make minus 10? Times together is minus 5 and minus 2, because minus 5 take away 2 gives me minus 7. Okay, and as I predicted, this minus 2 was going to be on the bottom, so we can now cancel it. So effectively, we've got 3x minus 2 all over x minus 5, x minus 2. Cancel these out, we're left with 3 over x minus 5, which we're going to put on our answer line. Okay, our next question is a circle theorem question. Okay, a really easy circle theorem question actually. As long as you know your circle theorems, you should know that a radius meets a tangent at 90 degrees. Okay, it's telling us in the question P is a point on the circumference of the circle, PQ is our tangent. Radius meets the tangent at 90 degrees. What is the size of the angle OPQ? 90 degrees. What is the reason? Because a radius meets, you can't see, meets a tangent at 90 degrees. Okay? So, next question. Adding fractions. What's the key thing we need to remember when adding fractions? We need to get the denominators the same. So first of all, what can we have on the bottom of both? Let's have a 12. Okay, what have I done to the 4 to get to 12? I've times it by 3. Therefore, I need to times the top by 3. What have I done to the 3 to get to a 12? I times it by 4. Therefore, I need to times the top by 4. Okay, now when I'm adding fractions, I just add the tops and then leave the bottom the same, right? So there's my 12. And I'm going to expand all in one go. 3x plus 9, which I've expanded that, plus 4x minus 20. Okay, let's simplify, tidy up. 3x plus 4x is 7x. 9 take away 20 is going to give me minus 11 all over 12. And there's your answer. 7x minus 11 all over 12. Okay, and final question. Prove that 0.473 recurring can be written as this fraction.